每次底下一个我一起在这好。然后那个我说点啊。那个，咱们是礼拜二、礼拜四的课，其实给咱们排的非常不好。这周课呀，要不然排1、4，要不然排2、5还好一点。2、4，你看礼拜二，如果你没时间，礼拜三看点什么，礼拜四我又讲了，所以你中间这个间隔特别少，而且不低于我礼拜二就礼拜四就教。所以往年我前2年的课全是1、4、2、5，或者说就是基本上这样调的比较好。所以今年我希望大家礼拜二讲的东西赶紧看，要不然礼拜四你上课之前没看，你觉得没听懂，礼拜四就没兴趣了。1次没兴趣不要紧，后边就跟不上了。完了就怕这个，你这次没听懂，就跟以前我上大学也是，一般听不懂以后，这门课索性就停着等期末再说了，这样不好啊。那个，所以咱们财科技还有几次机会，每月的这个月考啊，可以给大家提供一个机会，就是说阶段性的赶上。比如说我9月底考了1次，你至少把9月的大能赶上，然后你接着10月份好好听，后边也好好听。所以月考是非常重要的。Alright, let's keep going with classification of materials based on properties. Now, here we have examples of electrical properties, such as electrical conductivity and resistivity. Okay, we can classify material based on this kind of performance. Also, dielectric properties. So, what is dielectric property? Everyone knows electrical. Now, what about dielectrical? If you have 2 pieces of metal, now they are good conductors. In between the 2 pieces of metal, if you put a kind of an insulator in between, what is that? 好，刚才谁说的？说得那么好，刘老师说的，真好。如果有，我非常感动。我觉得我这么一说，他能说电容2个字来，我很欣慰啊。然后2个金属中间如果加一个 insulator，what is that? That's capacity. Capacitor. Okay, so the dielectric property for capacitors are very important. For example, they include polarizability. They can be polarized. One is positive, one is negative. Okay, now capacitance, of course, 这叫什么？电容的值。Okay, then they have ferroelectric properties, piezoelectric properties, or pyroelectric properties, depending on what is in between. OK， 这叫什么性能啊？给你们科普一下啊，我们这叫铁电性能，我们这叫压电性能，我们叫热势电性能。好，这些东西学材料课大4还不知道就行啊。Then magnetic properties, we can classify material based on this kind of need, or we say they include paramagnetic properties, or diamagnetic properties, or ferromagnetic property. 这回都知道了吧？都认识了吧？什么叫 paramagnetic？ 顺磁性，物理都学过，这叫什么？逆磁性、反磁性。这叫什么？铁磁性。ferro， 一见着 ferro 就是跟铁有关啊。ferromagnetic properties. Also, optical properties, they have refractive index. Okay, they have absorption, reflection, transmission. Okay, they have birefringence of lights. Okay, this is a double refraction. Now, also we have corrosion properties, we have deteriorated properties, and also biological properties. Okay, now one thing I need to mention here, biological property. If you try to develop or make a new biomaterial, one thing is very important. It has to be non-toxic. It cannot be poisonous, right? So toxicity of that material is very important. And also biocompatibility is very important. when you develop a biomaterial, you want to put that biomaterial into human body. Okay, it has to be compatible with your body fluids. Okay, so biocompatibility is very important. Then, when we develop a material, we want to achieve a comprehensive property of the material in our application. For certain applications, you want to have a better performance for a lot of properties. Then how do we choose a material if you want your property 1, property 2, or property 3 are all very, very good? Then in today's world, people tend to use this kind of HV plots to make a selection of material. So what HV plots does was they plot the log value of property 1 as a function of the log value of property 2. Now this property can be anything. They created a lot of HV plots for people to use. Okay, if you want to, for example, this is an HV plot. Now what is that? This is a fracture toughness. Okay, you want that material have a very good fracture toughness. Okay, now the higher the better, right? Then you want the material not to be too heavy. Then the log value of density is plotted here. So if you want to have a relatively larger fracture toughness, but a lighter material, you're going to look at this corner to select your material. For example, you want to choose a ceramic material. Oh, but ceramic material is kind of heavier. Then you want to look at polymeric material or polymer matrix composite. Okay, the fracture toughness is kind of high and also the density is kind of low. So by using this kind of an HV plot, you'll be able to pick a material or make a material selection based on your application. Okay, now this is just an example of a very simple HV plot. Actually, HV plots can be very complicated. It can be a generation of many properties. So this is one way that people use to make a material selection. Also, one thing I need to mention here is different material will behave differently or will exhibit different crystal structure and resultant properties. For example, I have two pictures here. What do you see? Where's the difference? What can you see from these two pictures? Where's the difference? Now, this is one specimen, specimen A, specimen B. What's the difference in their fracture surface? These materials are broken, right, by tension. If you pull that material and break it, what's the difference between this material, these two materials? You can see this one is elongated much longer. There are a lot of necking area in here. But that material is just going to break immediately. There's no elongation almost. Why? Why this is so? Why do different materials exhibit different properties? This is something we need to learn in this course. Okay, now we know specimen A is aluminum. Now specimen B is magnesium. So this is aluminum. Now this is magnesium. Why do aluminum specimen can behave differently as compared to magnesium? It can be elongated much longer.